So this is a short lecture on scripts. And hopefully by the end of this discussion, you'll be able to understand how to use scripts and arguments within scripts. So to understand scripts, we need to understand the concept of executable. What is an executable in a computing environment? So executables can be both adjectives. The term executable can be both an adjective and a noun. So as an adjective, an executable is indicates that a file or a program is able to be run by your computer. And an executable as a noun actually means that what you're looking at is an executable file or program, sometimes also referred to as a binary, although it's a certain type of executable. Programs are a series of instructions for a computer to execute in order to perform a specific task. And programs can be written in various ways. So they can be written in source code, which is basically a human readable file. Traditionally, an example of this would be a text file. And it'll be written in the syntax of a specific type of programming language. And then there are binaries, and these are non-human readable files, but they're easy for the computer to read. Think about binaries sort of indicating the zeros and ones that we know that computers sort of translate information into. And so what we end up is this sort of process by which we have source code. That source code then can be compiled into a binary. That binary can then be processed by the CPU, and then the CPU can then produce a result. In that case, you can see how if you write a program as source code, you're going to have to translate it for the CPU to be able to actually understand it. Whereas you have it compiled as a binary, you don't have to do that translation step. So when we look at Unix in particular, we are going to be mostly focused on writing scripts. And scripts are kind of a short, easy introduction to what a program is. So a script is a program. It's interpreted by another program rather than by the CPU itself. So this is a case where we can write code, actual human readable code, into a file, indicate a interpreter or a format, syntax for that code, and then that'll be translated so that the CPU can then execute it. In this specific case, we're going to be looking at the bash Unix shell as the interpreter of our programs. Generally, we would refer to this as a .sh file, but you could have a .bash file or really any kind of name that you want to use. But traditionally, that's what we'd say. So .sh for shell. When we think about what files are, it might help to understand like what an executable is, how we might see whether or not something is an executable. So when we think about files, they have attributes. So you can either read a file, you can write to a file, or you can execute a file. And so if we read a file, you can see what's in it. If we can write a file, we can change the contents. And if we can execute it, that means we can actually run the file as a program. When you look at how a file is described, it'll often have permission characters associated with it. It'll have an R that might be associated with it, a W, or an X, and these stand for read, write, and execute. And when we look at permissions, permissions are structured in three ways. There are permissions that are granted to the user, or the person who created that file. There are permissions that are granted to the group, and so what happens is a group of users may belong to an identified group, and then that group can have a certain level of permissions. And then there are just permissions that are allowed to everybody. So if we think of an example of what this looks like, if you were to type ls-l and you were in a directory, you might see something that looks like this. So this is the long list format of list, right? And we can see here, these are the permissions. And the way that it works is the first aside from this first position, positions 2 through 4 of this notation indicate the permissions that are available to the user. The next 3 indicate the permissions that are available to the group, and the last 3 indicate the permissions that are available to everybody. And one of the things that you might notice here is we've got a bunch of different type of text files. We've got an R script, we've got a Python script, we've got an SH script, and we also have a doc, a Word document, old-fashioned style. And what you can see is the different levels of permissions reflect how those files are viewed by the system. So notice that in all cases, the write permissions are associated with the user. So I am the user, Nate in this case. I belong to the group data. But notice that I am the only one, Nate is the only one who has write permissions. Everybody has permissions to read the file. So not only does the group have them, everyone in data, but everyone in other as well. And then for certain files, they actually have the permission to execute that file, to use it as a program. So both the group and everybody else. So we can see we've got a Python script and SH script. And what you can notice in this case is that both of those are already identified as executable files. Now, one of the things that you will see is that this R script here, diffexpresstest.r, is not identified as a executable. And that just means that I'm going to have to identify it and run it through R in order to execute it. So I have to take an extra step. Not that I can't actually execute it, but I have to take some extra steps in order to do so. So how do you run or call an executable? How do you execute it? There's basically two ways. If an executable is already an executable, you can just call the script name if it's in your path. So if it was run list extractor.sh, I could just type run list extractor.sh in my prompt. And if it was in my path, in other words, if it was in a environmental variable called path, which has a bunch of different locations in it where scripts might be located, if it's in that variable that I can see all these different spots, then I can just write the name and it'll run. Now, you can think of programs like ls and cd and mv and all these other programs already being in your path, right? They're actually in a directory. Often they're either in the user/bin or the /bin directory. But those are things that are already in the path. If something is not already in the path and I want to execute it, then I can do it two other ways. I can give it the full path location of that script, or if I'm already in that the same folder as that script, I could just do /the name of the script, and the dot stands for the directory that I'm in at that moment. If an executable is not a script, I actually have to give it the interpreter that's going to be used to call and interpret the program first. So if it's an sh file, if it's a .sh file, I need to say sh space script .sh. If it's a Python file, I need to say Python script .sh. If it's a Perl file, I do Perl script .pl, right? So in all these cases, that's what I need to do. There is a way to change permissions if you want to. There's a command called chmod, and you can look up some of the ways that how to use this if you want to go to this link. And there's a specific way that we might format bash Unix shell script. So every script is going to have a specific format. Generally, there's a general format that they would take, but they all have their syntax, but there's a specific one for each type. So first I'm going to talk about the bash Unix shell script. So the way the script structure works is that all scripts start with a shebang or a bang line. And this is basically the absolute path to the bash interpreter. So in this case, if I'm using a bash interpreter, I would say #!bin/bash. If I was using Python, I might say #!user/bin/python, wherever the interpreter for that program might be. Additionally, what other parts of a script that could be included? Typically, right after the shebang line or the bang line is going to be where we would put comments. And you'll notice here in this example, the comment is always preceded by a hash, by this little hashtag, by this number sign. So anything that's preceded by a number sign is not actually interpreted or read by the program interpreter. So that's a way for us to include things like instructions, descriptions, how the program works, and other comments about the structure of the program. It is very important to provide comments in your program. Otherwise, when you pass your code on to somebody else, they will not be able to they might not be able to understand it and able to use it effectively. Next, you'll notice that we have a series of commands. So we can have a series of commands. In this case, I'm using the echo command to output some print statements that are 100% true. Tongue in cheek, you can't see it, but it's firmly in my cheek. But you can execute a series of commands. You can also do things like pass arguments into a script. And in this way, when we actually call the script and run the program, we can put information in that command line command that can then be passed into the program and change the behavior of the program. You've already been using arguments in the class, things like ls space -l or grep space -c or awk space -f, right? In all of these cases, that -f, -c, -l, whatever, that's an argument, right? When you gave that extra little bit of information about that program, what it did was it changed the behavior of the program. And that's what arguments do. The reason why scripting is so important is once we learn how to do scripting and do it well, this is actually one of the big tools that we can use to build pipelines, right? And so this is where, we can basically take some initial information and then it'll go through a series of commands, changing various components, outputs, inputs, etc., until we get the result that we want at the end. So we can end up with a pipeline of commands all chained together. Again, arguments, these are values defined when a script is called and then is passed into the script. So an example of what that might look like is here, where we have the name of the script and then 1, 2, 3 arguments that come after it. So in this case, 305 is the first argument, Monroe County is the second argument, and FL for Florida is the third argument. And you can see here, this is how it's then interpreted by the script. So what it'll do is this $1, right? And dollar signs are typically used in Unix to indicate a variable. So $1, this variable, is the 305 of this first argument. So this first position after the script. $2 is the second position after the script, and $3 is the third position after the script. So that's a quick demonstration on how to use, or what scripts and executables are, and what their basic format and usage looks like.